Okay, in this last normal distribution problem, or not normal distribution video, I want to introduce the standard normal distribution, as well as talk about some properties, probabilities attached to standard deviations from the mean. And if you would take a stats class where you're using paper, pencil, calculators, and the back of a stats book, how you used to have to solve normal distribution problems would be to calculate a z-score, and then from that z-score, look in the back of a stats book for the probabilities given for a standard normal distribution, and then that would solve the original problem as well as the standard normal problem. And absolutely, you can do this in Excel. You don't have to, but you need to be aware that there is a normal distribution that has the descriptor standard in front of it. And all the standard means is that the mean has been hard-coded to 0 and the standard deviation is hard-coded to 1. And you can move from a normal distribution to a standard normal distribution anytime you want by calculating a z-score. Z-scores are just standardizing some random numbers. If you've got, I do a lot of research in golf, but I don't know everything there is about golf, and if we're talking about driving distances, I may not know what a typical or average driving distance is. So if you give me player statistics and I have a lot of driving distances on how far they hit the ball, I may not appreciate, and certainly people that aren't in golf may not appreciate what those numbers are. But if you standardize them by calculating a z-score for all of them, then you can see a z-score, and if you see z-scores that are exceptionally high or low, that can tell you something. So standardizing has the benefit of giving you a basis for looking at numbers even if you're unfamiliar with the underlying process. So there's value in using z-scores. And the formula is easy. You can take some specific, if you got a data set, calculate the mean, the standard deviation, and then for any value x, you can calculate the equivalent standardized score or the z-score. And then like I said, if you wanted to use and the traditional way to solve for a probability, you could take the z-score, go to the back of a book, or I'm sure these z-score tables are online as well. And once you solve that, the benefit of solving that problem, you're also solving the original problem. So let's do a quick example. So the one that I've got up here running right now is let's say that we've got a normal distribution with a mean of 10, a standard deviation of 3, and we want to know the probability that we're going to get a value that's 15 or less from a normal distribution centered at 10 with a standard deviation of 3. Now, we don't have to do anything other than use this Excel spreadsheet, and I can tell you the answer is 0.952. That is the formula that I've shown you how to do, and you have a video out. Let's say you didn't have this, and the only thing you had were standard normal stuff. So the first thing we could do is calculate a z-score. And the formula is taking the x value minus the mean, divided by the standard deviation. And then the standardized equivalent of this is 1.67. So on this normal distribution where I'm not showing any axes, but we know that on a normal, that this is roughly 10, and then that would be roughly 15. Well, that is 15. But on a standard normal, this is going to be 0 right here in the middle, and over here would be 1.7. So a normal distribution centered at 10 with a standard deviation of 3, it would be, the middle of this would be 10, and then this point would be 15. Well, I've already created another worksheet that is the standard normal worksheet, and let's just put that in. Let's put in this value, 1.67. So over here, I'm going to put, I'll just make that artificially small, don't worry about that. But on this one, I'm going to make 1.66667. And let's show some decimal places so that you know that it's the same thing. So look there. The probability that the area, see, it looks exactly like this picture. Look at them. This picture and this picture, the same thing. The area to the left of the original problem, 0.952, is that if we did not have Excel and we had to always use standard normal tables, we could do this, and this is what we would get. It's the same thing, 0.952. So that's the benefit of having, or that's how we used to do it, and you know that you can always go from a normal distribution to a standard normal, solve the standard normal problem, and you're also solving the normal distribution, the original problem. The other aspect I want to just remind you is that if you have a normal distribution with the mean and a standard deviation, you know exactly that plus or minus one standard deviation from the mean is 68%. Plus or minus 2 standard deviations, that probability of doing that, or the area between plus or minus 2 is 95. Between plus or minus 3 is 99.7. That's almost something worth memorizing. You don't have to, though, if you have this Excel. Let's just look at it in a spreadsheet. I've got my standard normal, and I've modified this. But if here's my standard normal, mean, standard deviation, and let's say I want it to be plus or minus 1. So minus 1 to 1. The area to the left of 1 is 84%, but the area to the left of minus 1 is 16%. The area between the lower and the upper, between these two numbers, is 68%, and that's what it looks like. Plus or minus 1 standard deviations from the mean, the probability of getting between plus or minus 1 sigma from the mean is 68%. What about between 2? 95%. Between 3? Probably need to show another decimal so that you can see the 99.7. There you go. 73, I guess is maybe a better way to say it. So those are properties that you can rely on. We do talk about these when we start into hypothesis testing. Okay, thank you.